Hello, sir. Sir, අපිට sir ඇහෙන්නේ නැහැ.
Good morning. Then hello. Then hello. Hello.
Okay, sir.
Yani?
ඔව් sir.
Right.
හරි. හරි sir
Very
ඇහෙනවා.
good. හොඳයි පුතා. මේ මට අද ලෙක්චර් එක චූට්ටක් කලින් ඉවර කරන්න වෙනවා. මේ මොකද පුතා මේ පේපර් එකක් තියෙනවා ඩෙඩ්ලයින් එක අද එඩිට් කරලා දාන්න තියෙන්නේ. හදිසි ඒ නිවුස් එක ඉතින් 12ට කලින් ලෙක්චර් එකක් ඉවර වෙන්නේ 12ටනේ. So I will stop this around 11:30 maybe. Yeah, let me continue this. නේද? හරි.
පැහැදිලි වෙන්නේ නැහැ.
එනවා මදිද? දැන් කොහොමද? දැන් ඇහෙනවද? හිලෝ?
ඔව් සර්.
හරිනේ? හරි පුතා. හරි. මේ slides one I have prepared this slide I think 1-2 years back. This is a very important presentation. And this one I'm not going to develop together with you, but to share this with you to refresh some of your knowledge and memories. Yeah. Just think about this. Matter, you know about matter. Matter needs space. පදාර්ථ වලට අවකාශයක් අවශ්‍යයි. ඒ වගේම matter occupies space. Matter occupies space means without space it is impossible for matters to exist. ඒ කියන්නේ පදාර්ථ වලට පවතින්න මේ අවකාශයක් අවශ්‍යයි. එනර්ජි වලට අවශ්‍ය නැහැ. But for matter it needs space for its existence. අවකාශ ධාතුව කියලා තියෙනෙත් ඒකේ නම් ලොකු aspects ගොඩක් තියෙනවා. ඒ කියන්නේ matter ගත්තත්. එතකොට අවකාශය space කියන එක that is something important parameter. ඒක නේද? matter වගේම the space. The space is very important. So whenever then පුතාලා වුණත් whenever because space cannot be physically seen. Space එක පේන්නේ මනසට. Yeah, so in any of the designs, if you can see the space, that is very important. Example, you see, මං කියලා දීලා තියෙනවා නේද? Engine design or whatever, you see there is a space. You are crafting somehow. So space is very important. How to say? Even a design factor. Yeah. So whatever in thermodynamics or in other engineering and technology, space is very important. Even in electronics, even in microelectronics, even in nanotechnologies. Yeah. Space is very important. Think about this. So in our case, in thermodynamics, we consider matter in limited quantities. Limited quantities means, this is of course very natural thinking, not that philosophical one. Limited quantities, let's say combustion inside an engine. Yeah. So you consider matter, it's in limited quantities. Boiling water in limited quantities, even an industrial boiler where the steam is generated, high-powered ones, still in limited quantities. So our case, when it comes to thermodynamics applications, we consider matter in limited quantities. This is another approach. So when the quantity is limited, space is limited. Yeah. So limited quantities and space we are considering all the while in thermodynamics. Even when you model clouds and all, weather and clouds, again it's about matter and space. There also the consideration can be for limited matter and space. Yeah. But Suppose it's in very big scales. Yeah. So that's how it is. Even in a compressor or a turbine, whatever, the limited matters means matter in limited quantities and in a limited space. So that's why පුතාලට පේනවනේ මේ slide එක. I think you can see this. Yeah. So I'm going to refer this to thermodynamics. Matter in limited quantities, how relevant this to us, Puta. Okay. Let's see. So we have matter. So you can see a box here. You can see a box. This box can be a generalized model because it's easier to construct, and you can see there is a space within the box, and of course this space contains matter. Let's example whatever, even වතුර බාල්දියක් ගන්නකො, you take a bucket of water, matter is there and the space is there. So even rice cooker, the matter is there, the space is there. Even in a kettle, matter is there, space is there. Even inside an engine, matter and space are there. Even in an air conditioner, matter and space are there. Even in a compressor or turbines, steam turbines, matter and space there. Air compressors, matter and space. So you can see this has a very general but very important relevancy. Yeah. So this may be another way of looking into thermodynamics. Yeah, so more basic understanding. So here you can see this box is the space. So you can see limited quantity of matter within this space. So the required spaciousness here is the volume of matter. Example, balloon bolයක් වෙන්න පුළුවන්. Okay. Even this can be a balloon with air. Yeah. So the volume of matter is the volume of the balloon inside, and the mass of matter is the mass of air inside the balloon. So mass and volume we call extensive properties, means volume depends on the extent of the space. Okay. And also for this extent of the space, the mass also based on this. Yeah. So somehow we call this mass and volume as extensive. Extend means extend කියපුවා මෙතන දැන් අපි හිතමුකෝ දැන් extent of a land. ඒ කියන්නේ land එකක size එක. ඒ කියන්නේ දිග පළල සමස්තය. So extensive means it is throughout, something like. Not to say throughout, it's considered, if you need to consider mass and volume, you have to consider the entire volume and entire mass. Extensive. Note එකෙත් තියෙනවා. Yeah. Yeah. Note එකෙත් තියෙනවා. In your textbook, text notes, you see extensive and intensive properties. So there is another property. Yeah. This is a very simple one. Density means how dense the mass in the space. Okay, how dense. How dense again, කොච්චර මේ සිංහලෙන් කියන්නේ ඝනත්වය කියලා. කියන්නේ that is okay. How dense the mass within the space. So within the space, how dense the mass means mass per volume. Means mass divided by volume. I'm circling here the density in this greenish box, middle box. Mass divided by volume. So this is the denseness, density. Also, then it's a kind of a property of matter. Again related to the space. Okay, volume refers to the space. So kilogram per meter. If we measure the space or the volume in meter cubes. Yeah. So we call this is not extensive property, this is intensive, because per unit volume. So per unit volume, this can be made of many unit volumes or even a fraction of a unit volume. So per unit volume means this is any more not necessary to consider the entire volume. Okay, that's why per unit volume. So this is intensive. So anywhere, if you take little piece of mass in the space, you have to consider the space as well. So you can look into densities. Example, density of water to evaluate, yeah, density of water. Even kaditi na 1 liter bottle, half liter bottle, or even a bucket of water. Wherever the density of water means the density of water can be the same. Yeah. So it has some independent from the total volume. And also this is something like the intensity. तीव्र गतिයක් වගේ तीव्र ගතිය, the intensity. So that may be the way this word intensive comes. Yeah. So that is the intensity of matter. So when you look into the other way, volume per mass, volume divided by mass means, then this is somewhat interested again. Per unit mass, what's the required space? That is what we call volume. Per unit mass, what's the required space? Yeah. So we call it specific volume. Again, a property of matter, and it's an intensive property, means you no need to consider the entire system. So wherever you take your specific volume, it has a common value. Okay, yeah, you no need the entire volume, but when it comes to the mass, the total one, mass in the space, you have to consider the entire space. Yeah. So that's why mass becomes extensive, and volume is the space requirement for the mass. But in thermodynamics, we consider volume also extensive, but volume is the space. Yeah, space requirement is the volume, but it's measurable. So again, it's related to the entire mass. So mass and volume are extensive. So these are the two major extensive properties. Yeah, there can be others as well. Example, the total heat content of this, extensive. Temperature can be intensive. Temperature intensive means you can use the probe or a thermometer. You can place anywhere, you will get the same value. Hopefully, yeah? Give me a second, Pratap. Give me a second. Okay, hang on, right. Okay, good. So let me go to the next slide, but before going to the next slide, keep it mind that keep it in mind that spaciousness is something, a kind of a third eye you should have. පේන්නේ නැති දෙයක් නේ පුතා, පේන්නේ නැති දේ ඒක දකින්න පුරුදු වෙන්න ඕනේ. So if you can see the spaciousness, the space, yeah, of mass as දෙකට පේන්න පුළුවන්. But space you may not see. But if you think of space, you can be innovative. You can be innovative. Okay, good. So let me go to the next slide. Let me go to the next slide. Give me a second for that. Okay. So I believe you can see this. අපි මේ වඳුරන්ට පත්තු කරා. මේ පැතිවල වඳුරු ඉන්නවා හරියට. Similar slide, okay, but you can see the mass, the space, required spaciousness, volume of matter, and you see the boundary, okay, of the surface is there. Surface of the mass maybe is the boundary, okay. Boundary, we consider it's a surface, okay. So outside the boundary we call surrounding. You can see right side, outside the boundary we call surrounding. That's how we identify. ගත්තත් දැන් අපි සහ පරිසරය කියපුවාම තමා සහ පරිසරය තමන්ට වෙනම කන්සිඩර් කරන්න බෑ. You have to think of your environment as well. පරිසරය. So here for this matter also there is a surrounding. So outside the boundary is the surrounding. So within the boundary, it is what is our interest. And we call it a system. Later we will look into this word. So, and density, again, still there to recollect this as intensive property. Then බලන්න පුතා, when you understand this density more than an equation, කියන්නේ density කියන එක සමීකරණයකට එහා දැනගත්තාම you feel a taste of that. You feel something special about density. Yeah, you feel something special. So never think density as mass by volume is an equation. It is not an equation, but it's a quality of matter. And we call it property as well. It's a property of matter. Density is not an equation. Property of matter means it is not a memory for you or just a word, but you should feel this. That's why I put on top, feel it. Yeah. So you have to understand, you have to feel it. So the intensity of spaciousness or specific volume, that is something special for you now. Yeah. You have learned this in your grade 10. Or even before that, maybe density or density. So what is density? Equation is there, mass divided by volume. It is quite funny, you know. So when something of physical phenomena limiting to an equation, your thought process is no more life. ස්වභාවික දේවල් තීරුම් ගන්න එක නැති වෙලා යනවා. කිසිම වෙලාවක ඉංජිනේරින් කියන එක සමීකරණයක් හැටියට, ටෙක්නොලොජි කියන එක සමීකරණ හැටියට හිතන්න එපා. But there are equations. You have to understand equations, but underneath the equation, something pretty much alive is there. You have to feel to that bottom. Okay, You have to feel to that bottom. Then you feel that, oh, density, it is something really, something massive to think. But if anyone think that, oh, density is an equation mass by volume, of course nothing to think. You should feel the difference, but not all the students feel this. හැම කෙනාටම මේක මේ විදිහට feel වෙන්නේ නැහැ පුතා. That is natural. But someone in your class may feel density is something special. Yeah. That speciality feeling comes when he feels the space. Okay? Yeah. So when he feels mass space all naturally, he or she can design even an engine better than the Ferrari engine. So that's the beauty. That's the beauty. Yeah? Yeah. So here mass and volume are extensive properties. Yeah. Also mentioned. So this slide introduces you the boundary, and the beyond the boundary is the surrounding. Okay, beyond the boundary, the surrounding. So again, you have the extensive properties and intensive properties. So our issue is that we are not that sensitive to the spaciousness. That is the issue. මිනිස්සුන්ට පේන දේ විතරක් ගන්නවනේ. පේන දේෙන් ගන්න දෙයක් නෑ ඇත්තට. What you are seeing is nothing but understanding through what you are seeing. That is very important. Understanding through what you are seeing. That is very important. ඇහෙන දෙයක් ගත්තත් ඇහෙන දෙයක ගන්න දෙයක් නෑ. ඒක තමන් කොච්චර දුරට ඒක තේරුම් ගන්නවද කියන එක මත තමයි ඉතින් මේක වැදගත්. බලක් ඇහුණත් එහෙමයි. උනට වැඩක් නෑ. ඒක තේරුම් ගන්න ප්‍රමාණයට අනුව තමයි ඒක වැදගත් තියෙන. ලෙක්චර් එකක් වුණත් එහෙමයි. That is very important. The way you grasp it, the way you understand it. Yeah. So matter in limited quantities. Also very nice about that. Because knowingly or unknowingly you are dealing with matter in limited quantities. Yeah. But you believe, Putana, we are universal beings. So we are talking about limited quantities, but if we are universal beings, we are not limited, you know. We are not limited. Yeah. You have to keep it in that mind as well. We are not limited. Even we should be able to grasp the space, the universe. විශ්වය කියන එක ගැන උනත් Tamanට හොඳ ග්‍රහණය කරගන්න පුළුවන්කමක් තියෙනවා. That is very important. And when you need to take the feeling of the universe, you have to understand the language of universe. Huh? Language of the trees. ගස්වලට කතා කරන භාෂාව ඉගෙන ගන්න වෙනවා. සුබාධමත් එක්ක කතා කරන භාෂාව. Those are secrets. I will tell you later. So those are different. But here, when it comes to thermodynamics only, just be limited to this. But don't be limited. If you are limited, I think that is not really good. Yeah, we are universal beings. By right, we are universal beings. But when we become limited, we may not be connected that well with the universe means. I think our objective of some kind of realization, we cannot get it. So don't be that limited, even though we are thinking in this way. Okay? Yeah. Good. That is a different story. Yeah? Yeah. Matters in limited quantities and its surrounding. Now, the topic. Again, matters in limited quantities, yeah, surrounding also there. Okay. Now I took here example. Oxygen. Yeah. So oxygen. Let's say oxygen in a balloon. Yeah. Balloon has a boundary surface. No matter the shape, a certain volume is there. Okay. So the boundary surface is there. The balloon, outside the balloon is the surrounding. Within the balloon is your system, the mass, oxygen. So what about the rubber part? The rubber skin. That is the boundary. Rubber is not oxygen, so it's not belongs to the mass we are considering. So that can be considered as surrounding even the rubber surface. It depends. Huh? Don't think that much. Yeah. So try to get a good understanding. The density term still there. The property of matter and intensive property. That is intensive property. Right? Intensive properties කියන්නේ මේ වගේ අපි හිතමුකෝ. වතුර ලීටරයක් ගත්තා කියලා. වතුර ලීටරයක් ගත්තා. තවත් ලීටරයක් ගත්තා කියමු. ওই ලීටරයක් කෝප දෙකකට දානවා. එතකොට වතුර ලීටරයක් තියෙනවා. තව වෙන වෙනම කෝප දෙකකටත් දානවා. වතුර. ඔය තුනේම ගත්තා density කියන එක same. So density is intensive. Specific volume is same. So specific volume is intensive property. Temperature can be same. Temperature is an intensive property. If you think of some other like viscosity, there is a term like that. It's the same. Huh? Can be like. But volume different. Mass different. So volume and mass different. So mass and volume we call extensive properties. ඒ හිතන තව විදිහක්. තේරුණානේ? Pressure. If you think of pressure, let's say, yeah, we will discuss that one later. Pressure also intensive property. Intensive property. Okay, in a gas. Okay. So density, again mass by volume. So let's say in the down box, you can see oxygen gas plus nitrogen gas together. Same space. Same space. So what is the space requirement of oxygen? It is the same here. What is the space requirement of nitrogen? It is the same here. That's how we take in engineering and technology. So volume of oxygen is V. Volume of nitrogen also same V. But mass of oxygen and mass of nitrogen is different. That's why you can see density is mass by volume. Here. So density of oxygen is mass of oxygen divided by V, the same volume within the boundary. Density of nitrogen, mass of nitrogen divided by V. So same space occupation for two different gases. Two different gases occupy the same space. එතකොට කියන්න බෑ. This space half needs for oxygen, half needs for nitrogen. No such thing. Oxygen molecules are free to move everywhere in the space. Nitrogen molecules are free to move everywhere in the space. So space belongs to all. So it's the same volume, but the mass change. You know what I mean? So oxygen and nitrogen like this part. Minisu. So when two students are in the one room, of course space is common, but you have space dedicated one. This is for you to place the table, your table, the other one's table, your bed, the other one's bed, and all. we divide the space, but when it comes to other matters with no consciousness, yeah, space is common. Even when you mix two liquids, let's say example, when you mix, so the volume can be the same. Yeah, anyway, later we will think, but for gas, surely this is the case. Huh? Surely this is the case. Yeah. I hope you can understand this. For gases, same space. For two different gases, if three different gases are still the same. For 10 different gases in the same space, the same space is the volume of individual gases. Quite interesting. But you have to understand this when you are using the gas laws and all. Yeah. When you are using the gas laws and all. So pressure because of oxygen and pressure because of nitrogen. Two things. We call those are partial pressures. Nitrogen, because of the nitrogen here in the space, there is a certain pressure. When there, because of the oxygen in the space, there is a certain pressure. So we call this separate because of nitrogen, that is partial pressure of nitrogen. Because of oxygen, that is partial pressure of oxygen. So together combined is the total pressure. Okay, later we will learn about this. Is the total pressure. But the volume, it's the same. Volume, it's the same. I took oxygen and nitrogen here because in air, and the dirt, mostly you see oxygen and nitrogen. More nitrogen and less oxygen. 70 plus nitrogen, 20 plus oxygen. 78 and 23, 77, 23%. You can check that. Okay, that's what we feel from this slide. Eh? Yeah. Yeah. Gas mixtures. So what's new here? Density here. The top box, it's only mass oxygen. Yeah. So density and of oxygen and nitrogen. So this one seems to be the same like the previous slide. Yeah, but there is a subtle difference. Matter in limited quantities, gas mixtures, the first one. This one, matter in limited quantities and its surrounding, the topic. Later comes to the gas mixtures, the title difference, that's on it. Yeah. So gas mixtures introduced in the previous slide, and the title placed here in this slide of gas mixtures. So gas mixture as a matter in a limited space. Space considered the same for individual gases. So this knowledge is essential. This knowledge is essential. Okay. So that's the one only introduced. Required spaciousness, volume of matter is the same V. Okay, that's all. Density is different, oxygen and nitrogen, mass of oxygen, mass of nitrogen, symbolic. Yeah. And matter and the surrounding is always connected, you know. Matter and the surrounding is always connected. The connectivity is there, okay? In terms of energy and work transfers and mass transfers through the boundaries. Okay, this is something, summary of what we have learned. Energy and work transfers and mass transfers means energy transfers. In terms of heat here, and the work transfers. Yeah. Let's say example from an engine, network is done from the system. In the compressor, network is done on the system. So heat also can be in both ways and mass transfers through the boundaries. So this is the connection. Matter and the surrounding, the connection. So you understand what matter, the surrounding, and now we are looking into the connections. This is the you and the surrounding. Yeah, this slide is there. So this one, you and the surrounding. So of course people have a lot of needs. Even knowledge can be one. So I mentioned here, we are learning actually, we are learning for all. Okay, so you should learn for those who didn't learn. So whenever you learn, it's on behalf of the others who didn't get this opportunity as well. So you have to have this very good attitudes. When you have good attitudes, your learning is naturally will be very qualitative and very strong. Yeah. So learn for you and those who didn't learn. Also have rich or get wealth for you and those who are needy. කෙඩි පොහොසත් වෙන්නේ තමන්ට විතරක් නෙවෙයි. දුප්පත් අය වෙනුවෙනුත් තමන් පොහොසත් වෙන්න ඕනේ පුතා. සල්ලි තියෙන්න එපා උදව් කරන්න. දැනුමක් තියෙන්න ඕනේ උදව් කරන්න. ඒකයි. You can earn millions and billions. That is all right. For you and for those who are needy means those who need. Yeah. Not all have the same wealth. Yeah. There are very much gaps in incomes. Some are really rich, filthy rich, some are extremely poor. No matter rich and poor, humans are human, lives are equally valid. Nature treats all the same, even in a COVID-C situation. So rich also affect even presidents. Some presidents also got infected. That's how the nature fare. So in your case, you can be rich for you and those who are needy. That's why, so we call this learning and being wealthy. It's a strength. So it's a strength really. Ek shaktiyak kiyala thamai ganna. Not physical, but even mental. So be strong for you and those who are weak. සාපේක්ෂව ඉන්නවා කියන්නේ ශක්තිය අඩු මිනිස්සු ඉන්න දුර්වලයි. So they need helps from the others. So you are the one to get strengthened, get stronger, and to support the others. So that's why, so we have to have very good this kind of attitudes, and we have to improve our way of life. Okay. So you should be strong enough. Even though now you are not rich, of course, your students, parents are supporting maybe. Yeah, that is all right. But keep in mind that you can be rich one day. So it is very important to be rich, you know. Yeah, very important. ලොකු අනිත්‍යයි කියලා මේ සල්ලි නැතුව ඉඳ ලැස් වෙන්න එපා. If you can earn, you earn for the others as well. That's why it is totally on the attitudes. Okay. Learning also the same. Yeah. Learning also the same. So you should be very good students with great attitudes. That is very important. This, especially this situation tells it. You may face difficulties, you may face challenges. Others may not be thinking as the way you are thinking. Others, yeah, those who are only think self means they are weak. Only think self is not a big deal. That is not a big deal. But how we can contribute to the others? How can be strong elements? How we can be the strong elements in the society? අන්නේකයි වෙන්නේ. දැන් politicians ලයිම ඔය ඡන්දය අරගෙන ඇවිල්ලා හොරගම් කරලා මඩිතර කරගන්නේ those are stupid fellows. But those are stupid fellows and they are really feel bad, you know. They are corrupted. Yeah, they have no brains, even no hearts. Those who are corrupted and those who steal the people's money and wealth. So we should not be in that category. Okay, we should be strong. We should be strong young adults. That is very important. So we have a surrounding, and of course we are universal beings, but of course before that you should be connected with your societies somehow through your brain and through your hearts. Then no corona issues. Yeah, you and the universe. Yeah, right side you can see you and the universe is there. Yeah, very good. I am skipping this because this takes 1 hour minimum time to complete this. This is very good. Essentials. Later we will talk about this. This takes 1 hour. Sometimes I used to share this, but now no time. Yeah. So that's it. So you know this now very well. The matter surrounding the boundaries and the connections of the matter with the surrounding, that is as energy and work, we call transfers. Okay, transfer from the system to the bound, system to the surrounding, from surrounding to the system. Transfers. Transfers. Mass transfers, energy transfers, heat transfers. සමහරලාට කෝච්චියකින් කෝච්චියකට මාරු වෙන්නේ. එතකොට කියන්නේ මාරු වෙන්න කියලානේ. Transfer from one train to the another. Transfer. Okay. Transfer. Plane එකකින් plane එකකට you are transferring in your travel. So he also transferred from the system to surrounding, surrounding to system. Quite interesting. Yeah. Yeah. So these are well explained, sir. These are well explained. So feel it again, matter and the surrounding, the connections. Now you can see the system word. Yeah. System is the matter of our interest. Of course, when matter of our interest, the matter of our interest is there, you cannot consider matter of our interest alone. You have to consider surrounding as well. So you have the system, surrounding, and the boundary that maybe hypothetically is separate system from the surrounding. Can be some imagined surface. So then energy and work transfers, mass transfers through the system boundaries. Yeah. So examples are here. You can think of running an engine, rocket propulsions, refrigerators, even global warming. Yeah, global warming also, it's about heat transfer and energy transfers. Weather, this all have the same thermodynamics phenomena. You can extend this to universal levels and more. When Samara Indo then go universal level itana ekatti tama astronomy and interesting so they feel the universe. So they like to learn about astronomies, astrophysics, astrobiologies, learning about the universe, black holes, and other phenomena. So some people they like it. Of course, that is not my interest, but I just mentioned that. There are some they like this kind of subjects. When they like, they really learn somehow. They really gain some knowledge. Yeah. So they are probably the better ones. Huh? So this tells about the state of equilibrium. Now, this is where we should start. The system and surrounding. No energy transfers, no mass transfers through the system. Means system is quite silently agreed with the surrounding and they remain silent each. No influences. Yeah. So it is that silence we call it equilibrium. So energetically, no connections. Yeah, means connection stopped. No energy transfers, no mass transfers. Means with the surrounding. Okay? Possible. Example, a glass of water. Let's say warm glass of water. If you put overnight, put temperature same as the surrounding. So no heat transfer between the glass of water and the room. No thermal connections. Of course, no mass transfers. If it's a warm one, you may have some evaporations. You may have some evaporations, but afterwards, no connections. Yeah. So looks like it's quite stabilized. Yeah. So you can imagine. So equilibrium. Equilibrium. Samatuliත වෙලා කියන්නේ samatuliත means it's balance. It's a balance. Okay. And sama means same. Somehow the equilibrium is different. So very good. This one. So no mass transfers, no heat transfers. අනික තමයි මේ if there are energy and mass transfers, you cannot simply isolate it from the system surrounding. You cannot isolate it. It reacts, so it transfers. Transfers means the system and the surrounding are connected. No transfers means you won't say not connected. It's connected, but it's in the state of equilibrium. Connection is there, but the state of equilibrium. That's why the connections, the state of equilibrium, matter and the surrounding. So this is again the same. So matter and the surrounding. The state of equilibrium means it just remains. Okay, just remains. Surrounding also, and the systems almost like no communication in terms of heat and mass transfers. Okay. So this one, initially somehow system can be in equilibrium with the surrounding. Example, water in a kettle. Before heating, there can be equilibrium, no heat transfer, example. But when you heat up, when you start firing, or when you on the flame, or when you switch on the heater, what happens? Yeah, system is receiving energy. Okay, so then the system properties are getting changed. Is no more initial. Is no more initial. So this is undergoing some heating. Heating is a process. System same temperatures. Surrounding with the surrounding no communications. System starts receiving heat. Temperature actually boiling temperature value, you can see that. Yeah, means the system is undergoing a process. That's what we call it. Process. We call it thermodynamics process. Yeah. Okay. Process. And after that, once it's reached boiling, maybe our process is done. We switch off it maybe. But you can see before starting this boiling process, we call initial state. Okay. So ending of the process we call final states. Okay. Final state. Final state. Initial state is definitely means almost in equilibrium for boiling water. But when you switch off at 100 degree, this looks still boiling, still warm, and still trying to getting cool down afterward. So after switch off, when water boils, you cannot say the system is in equilibrium with the surrounding. ඒක මොකද දන්නවද? මේක නිමෙන්න ගන්නවනේ. රත් කරලා ස්විච් එක ඔෆ් කරපුවා වෙන්නේ මොකද නිමෙන්න ගන්නවා කියන්නේ the system release energy to the surrounding. Yeah. So in real cases, final state may not be in equilibrium, but we can imagine that there can be processes. There can be processes, just imagination only, starting from equilibrium and end at the equilibrium, that is the final state. And this process, okay, this process, if this is very slow process, if it's a very slow process, still you can consider something like an equilibrium process. Temperature difference are very little, maybe even much lesser than 0.1 degree Celsius. Delta T very small. So churi temperature. So slowly, this takes long time, maybe 3 days of heating to make it boil. දැන් අපි විනාඩි 5න් රත් කරන්නේ. හිතන්නකෝ මේක අපි දවස් 10කින් රත් කරනවා කියන. Imagine we boil we will take 10 days process, 10 days heating process. So you can feel that this water boiling is extremely slow. Slow means the connectivity with the surrounding. It is something like near equilibrium. Not to say equilibrium is near equilibrium. Let's say we plan to make somehow, let's say we are designing to heat the water, to boil the water, to boil the water while heating for 10 days. දවස් 10ක් රත් කරපුවාම තමයි වතුර ටික රත් වෙන්නේ. Then now it's 5 minutes. We cannot wait but 10 days boiling. 10 days boiling. දැන් අපි හිතමු refrigerator එකක වතුර බීදුරුවක් තිබ්බොත් to come it to the set temperature of the refrigerator, let's say to reach 0, not in the deep freezer but in the refrigerator compartment, it may take 1 day maybe. Example in Coca-Cola, the Coca-Cola display coolers in restaurants. When you load full bottles at room temperature, it takes more than 24 hours to bring it down to the required chilled temperature, let's say of 7 degrees. ඒක දවසකට වැඩි යනවා. හරියට මේ cool temperature එක තියෙනවා. The same way, let's say this is a 10 days boiling, 1 liter. See how slow you are doing this. See how slow you are doing this. And in this design, you have questions. So you have to carefully craft this solution to make this boil slowly, gradually, rising the temperature in 10 days. You may have to have a different solution, but the process may be so slow that system doesn't feel that its temperature is getting changed. System එකට දැනෙන්නේවත් නැහැ temperature එක වෙනස් වෙනවාද කියලා. ඒ පොඩ්ඩනේ වෙනස් වෙනවා. Understand? If it's 100 days, 1 degree a day. Imagination, 1 degree a day. දවසකට වෙනස් වෙන අවශ්‍යක. පැයකට ගත්තොත් තප්පරයකට ගත්තොත් you don't feel the change. So for water that getting heated for 100 days to reach it to 100 degrees Celsius, let's say from 0. Yeah. So it is so slow that water doesn't feel that it's getting boiled. So it's a kind of equilibrium process. It's a kind of equilibrium process. Can you imagine? So you can imagine that kind of process. And even a reverse one also you can imagine. Yeah, you stop this after boiling for 100 days. Now you are letting this cool to the ambient. Again in 100 days. Cooling down is extremely slow. Surrounding doesn't feel that receiving heat. The system, the 1 liter 100 degree water now getting cool for 100 days to come to 0 doesn't feel that it's being cooled. තේරෙන්නේ නැහැ මේකින් මේ උණුසුම කියන එක යනවාද කියලා. තේරෙනවනේ? So doesn't feel that it's getting cold. And somehow that kind of very slow processes you can imagine. And all such processes throughout this heating or cooling process, you can imagine and assume that system is always in an equilibrium. Because the receiving heat is so negligible. In an instant, But during a time period, of course, it's receiving a big heat. It takes long and long time periods. So that's how you can imagine about that kind of, we call it reversible processes. Reversible. So always system and surrounding there is a balance. And somehow the process is getting placed. පුතලා imagine කරන්න පුළුවන් නේ? Imagine. That is only imagination only, not realistic most of the time. මං කතා කියන්න දෙයක්. One day, let's say if you happen to go to winter countries, සීතල රටවලට යනවා කියමු. We are from warm countries. When we go to winter countries, මෙහෙම දෙයක් තියෙනවා. සීතල කනවා කියන එක, we cannot subject it to cold. සීතලට අහු වෙන්න හොඳ නැහැ. Even though you wear the warm clothes, කාලයක් හිටපුවාම අපි හිතමුකෝ 6 months වගේ ඉන්නවා කියලා, 1 year. සමහර වෙලාවට සීතලට අහු වුණොත් the cold effect you feel to bones. You feel to the bones after months and months. And that effect can be negative. හිතා ගන්න පුළුවන්. එහෙම වෙන්න පුළුවන්. සීතල ඒ කියන්නේ. දැනින්නෙත් නේ උනාට ඇට මිදුළු වලට සීතල දැනෙනවා. මොකද තමන් ජීවත් වෙලා තියෙන්නේ warm country එක නම් සීතල රටකට ගිහිල්ලා. To feel that effect, to biologically to have that impact, it takes longer time, but there can be negative effects because we are not used to that. There are possibilities. So those are slow processes. So possible. Slow processes. Yeah. So initial, final. So the final state is different. You can see the different colors at least. The surrounding can be different. Yeah. So here we are introducing the process. Okay. The process can be fast. Fast means irreversible process. Okay. Fast means irreversible. So it is not slow with always to have a near balance between system and surrounding. No near balance. There is an imbalance. Significant heat transfer, significant mass transfers. Then it is not that we call reversible process. We move forward. So here the process, the connection. Matter and the surrounding, the connection is the process. So remember here, I didn't mention one thing. There should be time period. Delta T is there. Delta time period is there. So matter and the surrounding, I mentioned about the cyclicity. So initial to final, and then final to initial. Possible. Okay? Possible. Cyclicity. Cyclic. And if final to initial follows the same path reverse. Reverse එකේ හරියටම previous steps වල යන්න පුළුවන්. Means change the same way. So going in the previous steps. Back to this, we call it reverse. Okay? You can make the process cyclic. Making the process reverse is especially very special cyclic process. Okay? So you know what cyclic means. initial to certain stage final and back to initial, we call it cyclic, and can be in different ways, different parts. So, නුවරඑළිය ඉඳලා කොළඹ එනවා. හරි. නුවරඑළියෙන් ගිහිල්ලා අපි හිතමු ඔය බදුල්ල බණ්ඩාරවැල පැත්තෙන් කොළඹට එන්න පුළුවන් 60 මොකක් හරි එකක්. කොළඹට ඇවිල්ලා යනකොට යනවා කෑගල්ල නුවර හරහා ගම්පල පැත්තෙන් නුවරඑළිය. So you complete the cycle. Okay? But it is not reverse. ආපු පාරෙම යන්න පුළුවන්. Same way. So it is not to say reverse. Reverse can be opposite and reverse. You know reverse means in driving. Eh? Yeah. So that is reverse. So cyclic and reverse, two things. So the reversing of a process, it is a very stable low entropy process, and that reversible processes are not that real. You cannot make it reverse. It's not possible unless you do it in a laboratory. So steam tables are they may do even the cooling also, not only heating, and very slow processes. And now you can imagine. Eh? So you know cyclicity, and you know what reverse means. Yeah. So cyclicity again here, system passing, experiencing a process, so undergo a process, back to a final, and then through a different process. Can be through a different process, it can go to the initial, the cycling. Okay? It's cycling. If you can go back in exactly the reverse, we call it reversible process. Yeah, means you can make it reverse anytime. Yeah. Reversible process doesn't mean it's necessary to come back to origin, but the potential of reversibility is there. Okay? Reversible process, not necessary to come back to the beginning, but the potential of reversibility is there. But the cyclic process means it's coming back to the initial somehow, mostly through different paths, because processes are not reversible mostly. So that's how you can see the different processes, the color change. So coming forward one way, backward another way. Yeah, come back to the original. So original means the system and the surrounding world. Okay. Further. Introduced. No mass transfers. Only energy. The non-flow of matter during the process. The non-flow process. Closed system. So non-flow energy balance. Here you can see underneath non-flow energy balance through this process, experiencing the process. So whatever energy net receives in and out, total E net is the internal energy rise. So delta U is E. Interesting. Okay. No mass transfer. Work possible, heat possible through the surrounding communicates, through the system boundary communicate W and Q. So E is Q plus W, Q net plus W net. Net. Net කියන්නේ අපි හිතමු අපි අද තිබ්බා අපි හිතමු රුපියල් 100ක් තිබ්බා. 100ක් දුන්නා. හරිද 50ක් හම්බ වුණා. So net is minus 50. 100ක් දීලා 150ක් හම්බ වුණොත් net is plus 50. So that's all. So give and take the net value. Yeah. So same way, heat receive system, receive to the system, heat release from the system. The net received minus release, 150 minus 100. Okay, that is 50. 150 හම්බ වුණා 100ක් දුන්නා. 150 minus 100. So Q net is 50. Something like that. So Q net plus W net is E net. No mass transfer. So again, matter and the surrounding, the connections. So this is a closed system. E net is because work done on the system. Where this work goes. කොහෙවත් යන්නේ. Once work done, system energy level rise. What is that energy? That is we call internal energy in the closed system. E net is Q net plus W net. Yes. Good. So that's like this. Okay, very good. Now, again the closed system. Undergoing a process, you have initial state. We call it state 1, before process. Final state, state 2, after process. So process 1 to 2. No mass transfer here. So energy transfers only through the boundaries of closed systems. Energy transfers only. Okay, no mass transfer. So E here. So W also should be there. So the E is Q plus W from the previous slide. Q plus W is E. Okay, Q, heat, energy. So in this graph here, okay, not to say graph, but this is something like how to say in this column. You can see for this total E, that is a part from heat, part from work. Together it is E Q plus W. So because of this,
Excuse me, sir.
yeah, Buddha.
Sir, මේ ඔතන මේ E කියන්නේ අභ්‍යන්තර ශක්තියද?
මොකද පුතා?
E කියන්නේ අභ්‍යන්තර ශක්තියනේ.
E කියන්නේ පුතා මේකට හම්බ වෙච්ච එනර්ජි එක. හම්බ වෙච්ච ටික. net. E net.
ඒකට Q කියන්නේ
Q කියන්නේ ඒකේ E වල heat එක හැටියට ආපු ටික. හොඳ ප්‍රශ්න පුතා. E කියන්නේ ඒ එනර්ජි එකේ heat විදිහට ආපු එක. W කියන්නේ work විදිහට ආපු එක.
ඒ කියන්නේ Q කියන්නේ සර් පිටින් දෙන තාප ශක්තිය නෙමෙයිද?
හරියට හරි.
එතකොට සර් දැන් පිටින් දෙන තාප ශක්තිය නිසානේ උතන E කියන එකයි W කියන එකයි හටගන්නේ.
තාප ශක්තිය අපි හිතමුකෝ මෙහෙම එන්ජින් එකක් ගමුකෝ අපි. එතකොට එන්ජින් එකක නම් අපිට තාප ශක්තියයි W දෙකම කතා කරන්න වෙනවා. අපි හිතමුකෝ කම්ප්‍රෙෂර් එකක් කියලා. work done එකකුයි heat එකකුයි. ඒ වගේ ඒ කියන්නේ heat and work කියන දෙකම තියෙන්න පුළුවන්. හරි නේද?
ඔය Q නිසා අභ්‍යන්තර ශක්තියයි කාර්යයක් කරනවා කියන බැරිද සර්? ඒ පිටින් දෙන තාප ශක්තිය නිසා
නෑ පුතා මෙතන හිතන්නේ
අභ්‍යන්තර ශක්තියයි
ඔව් වෙන්න පුළුවන්. ඒක හරි. Q නිසා practically that is good. එතකොට දැන් මෙතන අපි ගන්නේ යම් විදියකින් තාපයක් සහ කාර්යයක් දෙකම මේ පද්ධතියට කෙරෙනවා නම් ඒ නිසා වැඩි එකතු වෙන අලුතෙන් එකතු වෙන ශක්තිය තමයි E කියන්නේ. මේ process එකේ අලුතෙන් එකතු වෙන ශක්තිය අලුතෙන් ලැබෙන ශක්තිය තාපයකින් සහ කාර්යයකින් අපි තුමු එක සැරේ කෙරෙනවා කියලා. හරි නේද ඒක? ඔව්. අනේ විදිහට මේ කියන්නේ ඔව් මේක මොඩල් එකක් පුතා මේක මොඩල් එකක්. හරි නේද? ඒකට මේක ප්‍රැක්ටිකලි ගත්තාම Q විතරක් තියෙන්න පුළුවන් W නැතු වෙන්න පුළුවන්. Q වලින් W කරෙන්න පුළුවන්. එක්සැම්පල්ස් ඉනවා ඉස්සරහට අපි හිතුවොත් එහෙම පිස්ටන් සිලින්ඩර් සිස්ටම් එකක් රත් කරපුවාම ඒකෙන්ම කාර්යයක් කරනවා දැන් ඔය කීවා වගේ. එතකොට ඒ හීට්
ඔව්
එකේ
සර්
කාර්ය ඔව් එතකොට
තාප
කාර්ය
ශක්තිය නිසානේ අභ්‍යන්තර ශක්තිය
ඔව් ඒ පුතා අර කොන්ස්ටන්ට් ප්‍රෙෂර් ප්‍රොසෙස් එක මතකයිනේ. ගිය සතිය කිරුව ඒ වගේ එකක් නේ. හීට් එකක් ඇප්ලයි කරනවා
ඔව් සර්
එතකොට සිස්ටම් එකෙන් වර්ක් ඩන් එකකුත් වෙනවා. එතකොට net heat එකකුත් ඉතුරු වෙනවා. මතකයි නේද energy balance constant pressure process. ගිය සතිය කිරුවේ. හරිද පුතා? let me continue.
හරි සර් හරි.
හරිනේ. ගිය සැරේ constant pressure process එක ඒකයි. පුළුවන් නම් මම ඒක ස්ලයිඩ් එක දාන්න බලන්නම්කෝ මේක ඉවර වෙලා. So E is delta U. E because of E internal energy change that is U2 minus U1. Okay. Oh, this can be Q net plus W net. E is Q plus W. Q means Q net. W means W net. Or you can write Q1 to 2 process Q12 plus W12. 1 is the initial state, 2 is the final state. Put the initial to final state. The process undergoes. The work done on the system is W1 to 2. The heat added to the system Q1. In a constant pressure process, you have Q12 is the external heating and W12 from the system. This can be negative. Later we will see. Yeah? When we do example, you will understand this clearly. And then comes the mass. If you have a certain mass, E by M, delta U by M, yes, lesson to explain it, Q by M, W by M. So small e, specific energy. Because of Q and W, energy received to the system. So specific heat, addition, not specific heat of the mass, but the addition per mass. Per mass. Or you can write as Q12 plus W12. Small ones. So these are non-flow energy balance. Non-flow energy equations. Time delta T is here. Time T to time T plus delta T. So there is a corresponding time. Okay, so here even can be the segment of a process. So you have during that segment, delta E can be the similar segment of energy. So delta E, delta U is U2 minus U1. Also possible. Don't worry about that, Putta, eh? Yeah. Yeah. So very good, this one. So matter and surrounding. So chapter 1 example, it's in your chapter 1. Eh? Yeah. So heating till boiling of water in an open pot. Examples. Yeah, non-flow energy balance. Heating till boiling of water in a closed container. And in a container with a moving piston like a lid. Heating till boiling of water in a closed container with a safety pressure relief valve to maintain the pressure level. Safety to make a massive so different, but still you can think of this. Vapor compression refrigeration system. Matter and surrounding. Okay. So compressor, initial final, because the working fluid is undergoing the changes when it's passing through the compressors, passing through the evaporators, passing through the expansion devices. Later we will learn refrigeration, don't worry. Yeah? Piston cylinder system, power stroke, whatever. So you can see matter and surrounding this interaction. We are considering in modeling of this and in understanding of this. I will later pass this to you. This example. This example is in your notes. Per kg. See, compressed air in a cylinder has, the cylinder already compressed, internal energy of this at the beginning of the expansion, because compressed air is getting expanded. Internal energy after expansion is this. So you have internal energy change from 440 to 220, means losing of energy. Losing of energy means sure this compressed air has done a work. So if the work done by the air during expansion is 120, by right, if this energy internal 440 to 220, 440 minus 220 is 220, means 220, the loss of internal energy, if converted fully into work, this is not 120, but this should be 220. So what happens to that 100? That is the heat loss. Now, if the work done by the air during the expansion is this, calculate the heat flow and explain whether it is heat addition or rejection. See your notes, it's well explained. Non-flow energy balance. So process 1 to 2, 1, you have 440 internal energy. At the end, you have 220 internal energy. The process, it's expansion. So internal energy change is the Q plus W. Okay. So Q12 plus work done in the system by the system means it is W is minus 120, U2 minus U1. So Q12 is minus 100. The negative sign means this heat loss from the system. So you go to your note, chapter 1 example, look into this, not just to look for the answer, but behind this, you can see big part of thermodynamics. Okay. Your internal energy loss, there is a heat transfer. Yeah. Because of the heat transfer, not the fully internal energy loss is transferred to work. So you can understand that. It's a very good practical example. Okay. But if you just think this as a formula, I think that is not very good as technology students. You should see this with some practical imagination, what kind of thing has been taken place. Okay, you refer your notes, look into this. Okay. Yes. What's the time now? 10:45. Okay, slowly. We are moving forward. This is a very good presentation, really, prepared by me. Yeah. No one else. Let's say energy required to raise the temperature of different substance. Here you will see the beauty of nature, Puta. That's what I want to highlight. You have 1 kilogram of iron, yakad, 1 kilogram of water. Okay. Dikin barawadi එකක් එහෙම තියෙනවද? ඉස්සරහන්නේ අර පුළුන් රාත්තලයි යකඩ රාත්තලයි barawadi මොකද්ද කියන්නේ? අහනව නේද? Here no such thing, it's the same mass, okay? Same weight. But of course 1 kg iron is smaller in size. kilogram එකක තරාදිපඩියක් හිතන්න. 1 kilogram of water is a 1 liter water bottle. Size wise it is big. And also raise the temperature from 20 to 30 degrees Celsius. Means to raise from 20 by 10 degree. Iron, yakada. And also water, also from 20 to 30. Energy, you need energy to rise the temperature. To raise the temperature. For this 10 degree rise, for 1 kilogram iron, it is 4.5 kilojoules you need. But for 1 kilogram of water, you need 41, almost 10 times. They're running. So iron and water, those physical matters, මේ භෞතික දේවල් වල ඒ කට්ටියගේ තියෙනවා මේ own strengths. වතුරට විශාල ශක්තියක් දරා ගන්න පුළුවන්. ලොකු thermal energy එකක්. යකඩ වලට ඉච්චර නෑ. තේරුණානේ? ඒ කියන්නේ මේ විශාල ශක්තියක් දරා ගන්න පුළුවන් හින්දා තමයි we are using water for power generation, steam power. වතුර පාවිච්චි කරන්නේ ඒකයි. තේරුණානේ? Because of that. Yes. 1 kg small, eh? Yeah. So size wise, 1 kg. Little big, okay, size wise. So 44.5 kilojoules, this is 41, almost 10 times. Okay, 10 times 4.5 is. Okay, give me a second. Yeah, Pita, sorry for the disturbance. Huh? Yeah. Anyway, yeah. So this is the one. Yeah. So you can imagine now almost 10 times. Huh? Yeah. So that value says 1 kg from 20 to 30, 10 degree rise is 4.5 kilojoule per kilogram per 10 Kelvin. Okay, per 10 Kelvin.
පැහැදිලිව ඇහෙන්නේ
ඇහෙන්නද පුතා? චුට්ටක් ඉන්න. Now should be okay. So based on the previous values, it's 4.5 for 1 kg, 10 degree rise. So 10 degree Kelvin and 10 degree Celsius same. So 4.5 kilojoule per kilogram per 10 Kelvin means for 1 Kelvin this is 0.45. Again, for 1 kg to rise 1 degree Celsius, so 1 degree Kelvin, the energy requirement for iron is 0.45. Okay. So see the top title, energy required to raise the temperature of different substances. I put this to understand the beauty of the nature of different substances. So when you have this sense, ඒ කියන්නේ පදාර්ථවල තියෙන මේ වෙනස් ස්වභාවයන් තේරුම් අරගෙන තියෙනකොට ඔය කට්ටිය දන්නවා ටෙක්නොලොජි වල ඒ metals appropriately use කරන්න. In thermodynamics, how to use. In strength of materials, how to use. ශක්තියකින් ගත්තාම in compression, how to use. In hydraulics, how to use. That is coming from your very best understanding of matter. For lubrication, what to use. තේරුණානේ? හරි සරලයි පුතා මේ බොහොම මේ ස්වභාවිකව ගන්න ඕනේ knowledge එකක් මේ පදාර්ථ ගැන මේ තියෙන දැනුම. තේරුණානේ? හැම එකකම මේ වගේ analysis එකක් තියෙන්න ඕන කට්ටියගේ ඔළුව වල. තේරුණානේ? එතකොට මේ you can come up with lot of miraculous solutions with no formulas. තේරුණානේ? water වල ගත්තාම see 4.18 kilojoule per kilogram per Kelvin. Air 1 kg air 20 to 30. What? 1 kg air 20 to 30, you need 10 kilojoules. යකඩවලට වැඩිය හුළං වලට ඕන වෙනවා 10 degree රත් කරන්න energy. So air has a better thermal retention. So 10 kg වලින්, so when you add 10 kilojoule of thermal energy, air temperature rise 1 kg from 20 to 30. But for 1 kg iron to raise 20 to 30, 10 kg, sorry, 1 kg iron to raise 20 to 30, 10 Kelvin or 10 Celsius, you need only 4.5. So for air heating, you need double the heat required for iron heating. So you can see that 2 times the specific heat capacity is the specific heat the 2 times the specific heat capacity of iron is the specific heat capacity of air. Specific. So specific heat capacity is an intensive property. 1 kg. You 1 kg you have the same value. So you have 10 kilograms of water. In that 10 kilogram, for 1 kg you have 4.1 specific. So specific values are always intensive. Same like density. Same like specific volumes. Yeah. So specific heat. So here you have a lot of, so I got this information, you can also look into this. So different substances, okay, aluminium, iron, steel, copper, brass, zinc, silver, mercury, and all, steam, ice, wood, nylon, rubber. You can get from this data, even in internet available, okay. Water, methyl alcohol, ice, steam, benzene, even marble, air at 50, you can see per degree Kelvin rise, okay, the joules, see the values, okay. So here this is C means, small c means specific heat, joule per kg per Kelvin. So we used to talk about kilojoules, but here in the table it's about joule. So you can see specific heat capacity of aluminium is 900 joules per kilogram per Kelvin, it's 0.9 kilojoule. Ice, it's more, 2.1. So it is more than double the specific heat capacity of ice. Wood also has a certain heat capacity. Copper, see, ceramic you have, copper, brass 380, rubber 170. කියන්නේ rubber වගේ එකක් සීතල වෙන්න ගොඩක් වෙලා යනවා. But brass can get it cooled fast because low content of heat. Even to drop 10 degrees Celsius, brass takes shorter period of time. One gold, lead 130, gold වගේ වගත්තා තව gold 130 joules. එතකොට 1 degree rise එකකට 130 means 0.13 kilojoule per kilogram gold metallic light side. So 0.13, but still it is 4.5. So 0.13 and 4.5, it is 40 times. So the gold will get 40 times less. Can chutak ketta gold kine ka atte. Nani chutak ketta atte na gold kine. මම හිතන්නේ ඒක වෙන්නේ නැති අර මේ සමහර වෙලාවට සත්තු වීම කාපුවම අර රත්තරන් මොන හරි අරගෙන ආව එතන තියනවා කියන්නේ ඒක මොන හරි ඇති ඒකේ. I don't know, but anyway, there may be some thermal effect as well, the thermal and of course the material effect, matter and thermal both. So you can see it. කොළ ಜಾති ගත්තොත් එක එක කොළවලු ආයුර්වේදයේ තියෙන කොළ ಜಾති different heat capacities. අහවල් කොළේ තිල් ගාලා රත් කරලා ගන්න so different the healing effects and so you can explore some technologies behind those traditions. See, hydrogen capacity 14,000, water 4,000, seawater 3,009. This is in joules. Steam 2,000. You know the hydrogen will be power. Hydrogen 14,000. Even hydrogen you are using for. Okay, I will say hydrogen is it's a very dangerous fuel. Yeah? Sometimes can be used as bombs, as detonation. So 1 kg energy content of hydrogen is 4 times the energy content of not 40, 7 times the energy content of steam. Steam will be 7 times very hydrogen power. Energy content. So not to say power, but releasing energy. There are a lot of energy content. Anyway, hydrogen in the power generation, so in bombs, it is the reaction, hydrogen plus oxygen, turning into water. Even in fuel cell technologies, they are using that. But you can see the beauty of the differences in values, unbelievable. See, AR718, steam 100 degrees, 2 kilojoules. At 100. Means to bring steam to superheat, 1 degree superheat, the steam at 100, to bring steam at 101 degree, you need this much of energy. Quite big, quite big and quite manageable. Heat capacity values of different substances, you can see. Different substances. Have a look in those Buddha and be sensitive to this, and even you can explore. You have to explore these substances. Don't wait until you graduate, So your job is learning and exploring, and you should know better than the lecturers. Okay, so you should know better than me when it comes to this kind of details. So, but in your side, you're picking up the knowledge. So you should be smart and handy enough to get the information, the important parts. That is very important. Yes. I put the hole here. What is this? So constant volume 1 kg air here, and constant volume, let's say, means that when you heat up the air, maintaining a constant volume, and when you heat up the air, maintaining the constant pressure. So to increase the temperature by 10 degrees, starting 20. So you can see for 10 Kelvin rise, or 10 degrees Celsius rise, for 1 kg, constant pressure you need 10.05 kilojoules. Constant volume you need 7.18 kilojoules. That's what we call CP and CV. Last week we have learned this. Yeah. Constant volume process we have studied very nicely last week under non-flow process. Constant pressure process we have studied very nicely last week. And the constant volume heat balance we call Q. Q is delta U. For constant pressure we learn the energy balance as Q is delta H. So we know that. And also the Cp, you have learned delta H is Cp delta T. You have learned delta U is Cv delta T for air, for gases. Okay. So here you have the connection with the last week lecture. Okay, now you have more sense of this Cp and Cv. Those are more than equations. Try to make sense out of this knowledge. That's why I mentioned all under feel it. Okay. The screen එකේ තියෙනවා මේ තුන්දෙනෙක්ගේ නම් තුනකට මේ display එක මැකිලා තියෙනවා. So can you take your video? Yeah, I think this may be my setting issue. Setting issue. Oh. Okay. So that's how Cp and Cv values. Cp lower, Cv higher. You know why is it? Eh? Yeah. Because when you heat up, you have to do some work as well at constant pressure. Constant volume, zero work. So heat whatever, it's for the temperature rise. It's for the internal heat rise. So that's the nature of the two different processes. Cp at constant pressure and Cv at constant volume. For gases, two types of heat capacities. I believe you can understand this. This is a very valuable slide. Enthalpy, you know this very well. U2 minus U1 is this. This slide, I have to share some extra knowledge for this one. Don't worry, this is a very simple one, but this is in your notes. CP-CV relationships for ideal gases. You're almost there to get this knowledge. So you look into these equations. This should be in chapter 1 maybe. So try to learn this. Text is given. Okay. So heat capacity ratios. Cp by Cv we call gamma. Okay. So we are using this heat capacity ratio in some analysis. So learn about this as well. It's in your notes. So you can see the Cp by Cv ratio, constant pressure to constant volume specific heat ratios. Cp by Cv. So you can see all here. 1 plus means definitely it should be 1 plus because during Cp, constant pressure process, some of the heat additions are going as work done by the system. So CVs can be small. So Cp by Cv highest is what? Hydrogen. See, there you will see the power. Capacity of gases. Hydrogen, even at 2000 degrees it's mentioned. At 2000 this is 1.3. You imagine 2000 is unbelievable temperature unit. 2000. That's why hydrogen is one of the substances scientists are telling that hydrogen is in the solar, the sun, one of the elements, maybe firing. I don't know. Yeah, it has quite high temperature values, 2000. Measuring 2000 is 2000 Celsius. I don't know what materials they are using for this preparation of chambers and all. Anyway, we'll explore this. Pretty high temperatures. Even furnaces, it's going below 1000 if I'm not mistaken. So helium 1.6, 20 degree. So at 20. Hydrogen 1.4. So helium, you have to release more work. So helium release more work means this has, how to say, Cp by Cv ratio high means for work done like applications, helium is possible because even there are Stirling compressors and the working fluid is helium. Even I have used those in some developments. Compressors, linear compressors, the working fluid is helium because of this property. 1.6 means against the constant volume, constant pressure, heat higher means you have more work done by the system. So helium is a good working fluid. Water also 1.3 can be a good working fluid, even 1.7. Air is a good working fluid. Air at 20 is 1.6. Air is a working fluid good because even in the piston cylinder engines, from the fuel combustion, you are heating up air. Okay, so you are heating up air. So in the engines, you can see the turbo power, whatever the working fluid is air. So you are heating up internally or externally, you are heating up the air by means of adding fuel and then do the combustion. Yeah, so working fluid in the engines is air. Keep in mind, not fuel, air. With a little bit of addition of combustion fuel there. Yeah, finally, it's air that is important. So air is a very good point for the work done. But for compressions, air may not be a good solution. You have to look for lower CP for compressions. Lower CP. We will see. Ammonia and all you can see. In H3 is ammonia. Lower CP. 1.3, still 1.3. You can see ammonia compression. Ammonia compressors in cooling, refrigeration and all. So try to understand the properties. Anyway, quite interesting. These things, Puta, I prefer to discuss in other sessions. So today, let me stop the class, because I have little urgent, unavoidable matter to attend. So it's 11:13, Puta. So we have done only for 2 hours. Hope you have done the. Hope you have gained something very special. Insight. We call it insight. Insight into thermodynamics by looking into these slides. So feel it. We need to continue. A lot to do. So let me continue it in the coming week. So after that, I will circulate these notes to you only after discussions. Till then, consider this as a helping hand for your notes. You have the notes, okay? So if I do the same notes on the screen, that is no point to you. It's a waste of your time. It's a waste of my time. So what I am doing is sharing some knowledge which is not there in the books, but it's an important more than the book contains. So that's how I am sharing with you. Again, පොතම මම කිව්වොත් වැඩක් නැහැ නේ පුතා. පොත මම විතර කරන්නේ කට්ටියට මෙතෙන්ට නෙන්නේ. You can do it by yourself. දැන් මම මෙතනින් කරන්නේ පොතේ නැතිවමක් තමයි කියලා දෙන්නේ. To become you, for you to become more competent and knowledgeable. You have to attend the lectures very well and use this as a helping tool for your notes. Note එක print out එකක් කරන් තියාගන්න. නිකන් screen එකේ බලන්න තියාගන්න එපා. මොකද screen එකේ බලන එක අමාරුයි. computer එක බලනවට වැඩිය පොතක් පෙරලනවා කියන එක that is good really. Maybe for our generation, book is always better than the screen, digital screen. Pulana puta print out you go through the book and you're supposed to do the assignment as well. You do it. Tutorial 1A if I'm not mistaken, do it and get the helping hand from this and we will discuss those as well. So for today anyway, let me stop the class and before stopping, any questions? ප්‍රශ්න තියෙනවද පුතාලට? ප්‍රශ්න ඇති අනිවාර්යෙන්.
Excuse me sir, මේ sir ඔය presentation එක එවනවද අපිට?
පුතා මේක ඉවර කරලා ඉවන්න. මම කියවන්නේ. ඒක තමයි කිව්වේ. මේක ඩිස්කස් කරලා ඉවන්න පුතා. හරිනේ? ඔව්. presentation එක ඩිස්කස් කරලා ඉවන්න. කවන්නේ නේ?
Okay sir. හරි.
ඔව්. අපි එහෙම කරමු. First we have to discuss this. So this feel it presentation, I'd like to share this, but Yeah, this is the time to share because we have learned about CP and CV, all the things. Now we are ready to learn some big things in thermodynamics because nothing big. When you feel the basics, I think that is the essentials, and when you have the essentials, we can move forward. No big deal. Don't worry about this. Don't worry about maths, but get a very good insight for thermodynamics. අර PDF drive එකේ thermodynamics පුත් තියෙනවා නම් download කරගන්න. හොඳ පොතක් තියෙනවා නම් මටත් recommend කරන්න පුතා. I will download that. Good. So let me stop the class now. Any more questions, Buddha? Any more questions? Any more questions? By questions, ne? You take care very well these days. Huh? චූටි දෙයක් කියන්න ඕනේ මේ කොවිඩ් කේස් එක ගැන. මේ දැන් ඔය මිනිස්සු මැරිලා වැටෙනවා නේද? ඇහෙනවද කියන එක? See yes or no to see tell the balance. So ඒකට හේතුව කියන්නේ පුතා මේ දැන් ඔය මැරිලා වැටෙන ගොඩක් අය මේ ඔක්කොමලා ගත්තාම කිසිම heart patient කෙනෙක් නැහැ. මොකද heart patient ලා බෙහෙත් ගන්නවනේ. ඒකට මැරිලා වැටෙන ඔක්කොම ගත්තාම heart failures කියලා කියන්නේ. ඒකයි වැඩි. දැන් lungs වල issue එකක් ආවොත් වෙන්නේ මැරිලා වැටෙන්නේ නැහැ නේ. හුස්ම ගන්න අමාරු වෙලා දඟලලා කොහමරි ස්පිරිතාලෙකට ගෙනින්න ventilator එකට දාලා somehow you have time. But in cardio system මේ හදවත සම්බන්ධ මේ රුධිර සංසරණ පද්ධතිය ගත්තාම එක තප්පරය යන්නේ මොළේට ලේ ගියේ නැත්නම් යුවගුණ. ඒකයි වැඩි. ඔක තප්පරින් වෙන දෙයක් ඕක. ඒකට ඕකට හේතුව හැටියට දැන් කියන්නේ මේ රුධිරයේ ඝනකම වෙනවා කියලා. තේරුණාද? ඔකට තාත්තලා ඉන්නවනම් 40s 50s වලින් කියන්නේ කොහොමද රුධිරයේ ඝනකම වෙනවා කියලා කියන්නේ. ඒකට පුළුවන් නම් ඔය herbs එහෙම තියෙනවා නම් ඒ කියන්නේ blood circulation එක හොඳ වෙන්නේ. ඒ කියන්නේ රුධිරයේ ඝනකම වෙනකොට තමයි blood clots එන්නේ. අර leak හැටින්නේ flow එකක් තමයි blood clot. පුතාට ඇහෙනවද මං කියන්නේ හොඳට අහගෙන ඉන්නේ ඔය කට්ටිය? අහගෙන ඉන්නේ. ඔව්. මේ ඔව්. ඒකට ඔය blood clots කියන්නේ leak හැටි හැදින්නත් පුළුවන්. රුධිරේ ඝන වෙච්චාම flow එක අඩු වෙලා heart එකට load එක වැඩි වෙනවා පුතා. ඔන්න ඕකයි ප්‍රශ්නේ. දැන් ඉතින් ඒකට කොහොම බයයිනේ ඇත්තටම. දැන් ඔහොම වෙන්නේ heart patient ලා කවුරුවත් මැරිලා නැහැ. මැරෙන්නේ මේ හොඳට ගස්ගල් වගේ ඉන්න මිනිස්සු තමයි මැරෙන්නේ. I'm telling this in Sinhalese. I hope all can understand this. ඕක තමයි කේස් එකේ වුණාට ඕක දොස්සර්ලා කියන්නේ නැහැ, කවුරුවත් කියන්නේ මේක හිතා ගන්න බෑ. ඊ කමල්සෙත් කතා කරුවා මේක තමයි කේස් එක. මේකට තියෙන එකම දේ ඔය කට්ටිය බලන්න හරිද? මොනවද herbs ಜಾති තියෙන්නේ කියලා. ඒ කියන්නේ blood clot avoid කරන herbs. side effects නැති ඒවා. තේරුණානේ? side effects නැති ඒවා මොනවද කියලා බලලා ඒවා ඒවැ තියෙන ඉෆෙක්ට් එක අපි හිතමු අද ඒ herb එක තම්බලා බීවා කියලා ඔක සතියක් තියෙනවනේ. දවස් 5කින් පස්සේ ආයෙ බොන්න පුළුවන්. තේරුණානේ? ඔක වෙද මහත්තුරුම දන්නවද ඒක එක්ස්ප්ලෝර් කරලා බලන්න. මේ ෆාමසි තියෙනවා ඔයාට හොඳ දේ. දොස්තරලවා කියන්නේ ඉතින් මට බෙහෙත් කියන්න බෑ මම දොස්තර කෙනෙක් නෙවෙයි ඉඳලා. මම දැනගත්තත් මම දන්නවා බෙහෙත් මොනවද කියලා. මොකද එහෙම ඉතින් මුළු රටක්ම මේ බ්ලඩ් ක්ලොට් නැති වෙන්නේ කියලා බෙහෙත් දීවොත් ඒකත් අවුල්නේ. ඒකනේ. ඒකින්ද මේකට මොනවා හරි මේ බලලා මේකට තමයි ආන්සර් එක උනේ තියෙන්නේ. කොහොමද හැදෙන්නේ කියන්නේ ප්‍රශ්නේ තියෙන්නේ ඔන්න මේවා මේ කොලැප්ස් එක. ඒකයි. කොලැප්ස් එක ගත්තාම දැන් කේසස් තියෙනවා කොලැප්ස් නොවි වුණා. ඔය බෝඩර් එකේ ඉන්න කේසස් තියෙනවා. ඒකට ඒ කට්ටියට long term health effects තියෙනවා. ඒකයි. ඒකින්ද පුතාලා මේකට මේ ආන්සර් එකක් අදට හොයාගෙන මටත් කියන්න. විදමහතුරුන්ගේ ෆැමිලිසුත් ඇති ඔය කට්ටිය අතර මේ වෙලාවේ කියන සයිඩ් ඉෆෙක්ට් එකක් නැති වෙන විදිහට හර්බ් එකක් බෝයිල් කරලා සතියකට දවසක් බීලා ඔය ප්‍රොබ්ලම් එක අවොයිඩ් කරගන්න පුළුවන් නම් හරි නේද? සයිඩ් ඉෆෙක්ට්ස් නැතු. අරිස්ටාරෝම බොන්න යන්න එපා. මේ මම දන්නේ කොහොමද කියලා. මොකද මේ ෆීල්ඩ් එකේ නෙවෙයිනේ අපි උනාට මේ දන්නේ එක කියන්න ඕනේ. හින්දා මම මේ කියන්නේ. මේ පුළුවන් නම් මේකට ප්‍රිවෙන්ටිව් මොනවා හරි කරගන්න ඕනේ. දැන් අපේ ඒජස් වලදී අපි නම් ඔය පොඩි ඔය සප්ලිමන්ට්ස් හරි මොනවා හරි ගන්නවා බ්ලඩ් ක්ලොට් නැති වෙන්න. as preventions even I'm taking 4 years එහෙම ගන්නේ මොකද මේ හදවතේ ලෙඩ තියෙන්න ඕනේ නෑ. ඔය බ්ලඩ් ක්ලොට්ස් කියන ඒවා හින්දා වයසට යනකොට මිනිසුන්ට එනවා පුතාලා. ඔය කට්ටියගේ වයස දිහා වෙන්න තුනට දැන් මේ මෑතක මේ ළඟ අවුරුදු 20 ගානක කෙනෙක් කලැප්ස් වුණා. මැරෙන්නම කලැප්ස් වෙලා. පැටිනකොට මැරලා ඉවරයි. ඒකයි එකම රීසන් එක ඕක තමයි. නැතු ටෙන්ෂන් මැරෙන්න බෑ මොකද කවුරුත් පණ උඩින් අරගන්නේ නැහැ නේ. එහෙම දෙයක් නැහැ නේ. ඒකට අරක තමයි රීසන් එක. කාඩියෝ සිස්ටම් එකේ එන ප්‍රශ්නේ ඒකේ ඉන්නේ බ්ලඩ්ස් වලින්. තේරුණානේ පුතා? ටික මේ ප්‍රශ්නේ ඇවිල්ලා ලිමිට් එක පැන්න ගමන් Taman දන්නේ නැහැ. අනික අපහසුතාව තිබ්බට මිනිස්සු කීයක ඉන්නේ නේ මට මහන්සි අමාරුයි කියලා. ඉතින් මිනිස්සු වැඩ හිටියෝ ඒ වැඩ ටිකනේ කරගෙන යන්නේ පුතා. ඒක පොඩි අපහසුතාවයක් දැන්නට මිනිස්සු එහෙම කියන්නේ නැහැ එක එක්කෙනා. තමන්ගේ තාත්තා වුණත් ඉන්න පුළුවන් මේ අපහසුතාවය දැනගත්තට කියන්නේ. අය උන් කට්ටිය උනත් එන්නේ අපහසුතාවයක් ආවොත් උනත් තිබ්බට කියන්නේ මොකද we are strong enough to bear it. ඉතින් මුතනදී මේ උකට විසඳුමක් කල්පනාකාරීව ගන්න බලන්න. තේරුණානේ? ඔව්. මොකද ඒක මේ ඉන්සිඩන්ට්ස් එන්න වැඩි. දැන් ඊ පානුපුරේ කේස් එක තිබ්බ හැමදාම නිවුස් නේ. අනික දැන් මේක ඉස්සරහට වැඩි වෙන්න පුළුවන් නේ. මේ මැසේජ් එක හම්බුණා නේද මං කියපු එක පුතාට. ඒ කියන්නේ තීරුණානේ මං කිව්වේ මොකක්ද කියලා. නේද? So you have to look for some answers. මේ මගේ බේත් අහන්න නම් එපා. But there are medications, but you have to take under doctor's supervisions. දන්න කෙනෙක් ඉන්නවා නම් අහලා බලන්න. ඉතින් අහලා බලලා ගන්න. But don't take aspirins and all. Aspirin, dispirin, ඒවා මේවා ගන්න යන්න එපා. ඊතුමන අපිට that is very risky. Unnecessary side effects are there. There are safe medicines anyway. Look into those and ask for the local Ayurvedic doctors and get something as prevention of this COVID attacks. තේරුණානේ? මේ මැසේජ් එකකින් කාගේ හරි මොනවා හරි ඉතින් කවුරු හරි බේරෙනවා නම් මේක ලොකු දෙයක්. මේ බලන්න පුතාලා. හරි නේද කියපු එක? තේරුණාද? තේරුණාද ළමයි? තේරුණානේ? හිලෝ?
ඔව් සර්.
ඔව් සර්. ඒ පොඩ්ඩක් පුතා ඕක එක්ස්ප්ලෝර් කරලා බලන්න බෙස්ට් එකක් ෂෙයා කරගන්න. ඒ කියන්නේ that is essential. ඒකයි. ඔය රිස්ක් ගෲප් එක තියෙන්නේ සාමාන්‍යයෙන් 40 to 55 වගේ. 25 to 55 කියලා කියන්න පුළුවන්. ඔබ සමහරවිට ජෙනටිකලි තියෙනවා. 20s to 15. ඒකිනේ දැන් වයසක අය කලැප්ස් වෙන්නේ නැහැ. මොකද ඒ කට්ටිය කාඩියෝ අරවා මේවට බෙහෙත් බොනා එහෙම නින්නේ වයසක අය තියෙන්න පුළුවන් බැරි නෑ. මේ මේ කේස් එක ගත්තාම තියෙන යං ගෲප් එකේ. අනික සමහර ෆුඩ් ඇති අවොයිඩ් කරන්න පුතා. සමහර අවොයිඩ් කරන්න ෆුඩ් ඇති විශේෂයෙන් ගත්තාම කොලෙස්ටරෝල් ලෙවල් වැඩි වෙන ෆුඩ් එහෙම ඉච්චර ගන්න එපා. මස් අරව මේවා. ඊවේ මට හිතෙනවා මේ ටිකක් අර බ්ලඩ් තික් වෙන ගතිය තියෙන්න පුළුවන්. ඊට පස්සේ වතුර බොන එක උණු වතුර ටිකක් එහෙම වැඩිපුර දෙන්න. උණු වතුර බොන එකෙන් ගොඩක් ලෙඩ කොවිඩ් එකට උත්තරයක් කියන්නේ සමහරට ඔබ බ්ලඩ් සර්කියුලේෂන් එකටත් උණු වතුර හොඳද දන්නේ. අන්න එක අපි කියන්නේ වතුර බොන එකෙන් මේ සනීප වෙනවා කියන්නේ මොකක්ද වෙන්නේ කියලා අපි හරියට දන්නේ නැහැ. සමහර අය කියන උගුර බැක්ටීරියා එක වෛරස් එක මේ සෙටල් වෙනවා කියලා. වතුර බොන අයට වෛරස් එක ඇඟේ තිබ්බත් අඩු වෙනවා කියලා කියනවා. ඒක අපි දන්නේ නේ. ඒකයි. ඉතින් ඒකින්ද මේ ඕකට ආන්සර් එකක් තමයි පුතා නැත්තේ. තේරුණා නේද? මොකද ඒක නෝටිස් කරන්නේ නැතුව නෙවෙන්නේ. ඒක නෝටිස් කරන්නේ නැතුව වෙනකොට ඒකට වෙලාවක් නැහැ මේ රෙස්පොන්ඩ් කරන්න. මේකයි. ඒකින්ද මේ චුට්ට බලන්න පුළුවන් නම් ඔය මේ ෆුඩ් ඩයට් එහෙම බලලා ඔයාට හොඳ මේ සොලියුෂන් එකක් ගන්න පුතා තියෙනවා නම් මටත් මේල් එකක් දාන්න. හරි නේද? මොකද මේ කඩවල වල බෙහෙත් තිබ්බට ඔයා ඔක්කොම ජනතාවම ඔය කිමිකල්ස් ගන්න ගත්තොත් මේකත් මහ විනාශයක්. But you can look for very promising supplements, Ayurvedic supplements. Not expensive. තියෙන්න පුළුවන් දේවල් සමහරවිට ඔය ගොරක ගැල්ලක් වැඩිපුර පොද්දකට දාන එක වෙන්න පුළුවන් පුතා. අපි දන්නේ නේ ඒක. දැන් අපිට ගොඩාක් ඔය knowledge එක ගිහිල්ලා තියෙන සමහරට herbs මොනවා හරි වෙන්න පුළුවන් ඕකට දාන්න තියෙන. ඒක දාලා කනකොට අඩු වෙන්න පුළුවන් සමහරට ඕක cinnamon කුරුඳු වෙන්න පුළුවන් කරාබු වෙන්න පුළුවන් අපි දන්නේ මොනවද කියලා ගොරක ටිකක් වෙන්න පුළුවන්. තෙල් අඩුවෙන් වෙන්න පුළුවන්. මොකක්ද කියලා දන්නේ නැහැ. බීට සූප් එකක්ද මේ හීලිබත් ටිකක් ආපුවාම අඩු වෙනවද මේක දන්නේ නේ. ඒකින්ද දැන් පුතා ඔන්නෝගේ knowledge එක හොයාගන්න ඕනේ. ඒකයි. මේ හැමදාම මැරිලා වැටෙන එකෙන් තීරණ එකක් තමයි අපි මිනිස්සුගේ ලයිෆ් ස්ටයිල් වල ප්‍රශ්න තියෙනවා. අපිත් ඇතිලු. ඒකයි ෆුඩ් හැබිට්ස් අරන් ඒවා. කොහොම ටික බලලා පුතා මේ මොන හරි උත්තරයක් ගන්න බලන්න මේ මටත් අප්ඩේට් එකක් දෙන්නකෝ ඊමේල් එකක් දාන්න. හොඳයි එහෙනම් පරිස්සමින් ඉන්න ඕක තමයි කියන්න තියෙන්නේ. So be safe. බය වෙලා ඉන්න එපා. Be safe. You have to lead your families and the societies මේ වෙලාවේ. බයෙන් හැංගිලා හරියන්නේ නැහැ. මේක ඉතින් තාවුන් විසුම් නැති ඉතින් නැත්තේ නෑ. even spiritual aspects. They can be the spiritual වල තියෙන scientific aspect එක අහුවෙන්නේ නැහැ. scientific aspect එක අහුවෙන්නේ නැති වෙච්චාම මිනිස්සු මිත්‍යාවල් කියලා අයින් කරනවා spiritual aspects. දෙපන් පුතා. මේ ඒකින්ද පුතා මේ ඒක චුට්ටක් බලන්න ස්පිරිචුවල් ඇස්පෙක්ට් උනත් බලන්න. ඒවා තියෙන සයන්ටිෆික් බේස් එකක් තියෙනවා ඒක. ඒවත් බලන්න මේ කොහොමද බලන්න හොඳට මැනේජ් කරන්න බලන්න. Right, that's all from my side. So take care. Good day and good luck. Bye for time. See you next Friday. Take care. Okay. Bye.